Welcome back students. Last video we had discussed on the components of horizontal axis wind turbine. In this session we can see the working of horizontal axis wind turbine. Today's wind turbines are capable of converting a great amount of energy in the wind into electricity. This is due to the blades which are developed using state-of-the-art aerodynamic analysis and the other performance enhancing equipments. If the blowing wind can turn the blade, we will receive electricity from the generator that is attached to it. In your mind you are having a question, how does the blowing wind turn the blade? The blade has a lot of airfoil cross sections consisting of different sizes and shapes from the root to tip. The simple airfoil technology makes the wind turbine blade turn. That means that a lift force is produced when a fluid moves over an airfoil. This way the wind turbine achieves basic rotation. Just an moving train, you experience things relatively. The moving wind turbine blade also experiences the wind relatively. For the moving blade, the relative velocity is as shown. This is the blade. We know we are having single blade, two blade and three blade system. Here this is the velocity of wind and this is the velocity of blade. The net relative velocity is wind velocity, the difference between wind velocity and blade velocity. Therefore, the wind turbine blade is positioned in a tilde manner in order to align with the relative wind speed. As the blade velocity increases to the tip, the relative wind speed becomes more inclined towards the tip. This means that a continuous twist is given to the blade from the root to tip. However, this rotation cannot be directly coupled to the generator because the wind turbine blades typically turn at a very low rate of RPM due to the issues of noise and mechanical strength. Considering this low speed rotation, we cannot produce any required electricity frequently from a generator. As you know, the RPM produced from this blade is very less, so we need some mechanism to increase the speed before connecting to the generator. So before connecting to the generator, the speed is increased in a gearbox. The gearbox uses a planetary gear set arrangement to achieve the high speed ratio. A brake also sits in the nozzle. The function of the brake is to arrest wind blade rotation during excessive wind conditions. During excessive wind condition, we are using brake to arrest the wind turbine. Cutoff speed is 80 km per hour. Consequently, the electricity that is passed through the cables towards the base where a step-up transformer is situated. Usually we know the electricity generated is in very low voltage, so we want to install a step-up transformer in the grid itself to increase the voltage before transferring or transmitting to the grid. The wind turbine should face the wind normally for maximum power extraction, but the wind direction can change at any time. A velocity sensor on the top of the nozzle measures the wind speed and direction. The deviation in the wind's direction is sent to an electronic controller, which in turn sends an appropriate signal to the yaw mechanism to correct the error. What do you mean by yaw control? Yaw control continuously tracks and keeps the rotor axis in the wind direction. Suppose the wind orientation or direction is changed, we are using a yaw control to track it and keep the rotor axis in the wind direction. You can see how the yaw motors turn the nozzle. Thus, the wind turbine will always be aligned with the wind direction. According to the wind speed, the relative velocity angle of the wind also changes. A blade tilting mechanism tilts the blades and guarantees a proper alignment of the blade with the relative velocity. Thus, the blades are always at the optimum angle of attack with the relative wind flow. The efficiency of the wind turbine in the really interesting one. Efficiency will not exceed 59.3% in wind turbine generation. As you know, India ranks 5th in wind generation. Around 45,000 megawatt of electricity can be generated by India if it is fully utilizes its wind potential. Now we can see a video. Muppattal wind farm is the largest wind power plant in India with 1500 megawatt installed capacity. This is a captured video from Muppattal for your reference. You can see the windmill structure, its foundation, tower, etc.